So in figure 19, we're showing the bottom end cap. In figure 20, we're showing the top end cap. These end caps are crucial for creating a solid seal around each of the each end of the reactor. From there, to create these, and the reason why we have two holes in the bottom is we needed to allow for the static mixer to input into one area and the output of the glycerol, which is the byproduct, from the reactor. And the top only has the one because we only need to export the one, or the biodiesel itself. And to create these, we used a simple we used the CNC machine to get a 1-inch groove, or half-inch deep groove that's seen here, in here, and then just drilled through the aluminum pieces to create our holes. And then here's our complete assembly of what we designed, and then comparing it to the actual piece itself. We were able to replicate it fairly efficiently and correctly. The basic rotation system is based off of two bearings on each side to provide equal support for each set, or each side. And I'll pass it off to Caleb for the plumbing.
Thank you, Brian. I'm Caleb Seek, and I'm going to be presenting and discussing the plumbing that we used on the project, and maybe some of the problems that we ran into based on design and what actually happened. So this is just a general overview of the overall reaction itself and the tanks as well as the reactor, and I'll be discussing the individual sections further on. The plumbing itself, so we were intending to use like hard PVC pipes in the beginning because clearly, as stated before, they're suitable for the products that we're running through them, and they're large enough to run the fluids well, but we ran into some problems with not knowing exactly where we were going to run, or some size differences, so we decided to move to a vinyl tubing for some flexibility, so to say. And that would allow us to run it in different areas, as well as work with the nylon couplings and brass couplings that would allow us to connect the different sizes that we had obtained. Because many of the valves and systems that were purchased didn't quite match up in sizes. We had some 3/8-inch valves, and this was mostly due to cost constraints, because it was very hard to find valves that were suitable for oil and were precision enough. So we purchased what we could and then used couplings to get through the rest. The vinyl is admittedly not a perfect solution, but at the current state of design, the ability to see what's running through it, and it won't run for forever and it would need to be replaced. But right now, it makes a very good, suitable replacement for the current state. 2 precision manual valves are used. They're connected on the stand that contain the tanks. This is what we use to make sure that we have the right ratio of fluids entering the reaction chamber itself. As Dave stated, we have 42 inches of static mixing, the 36 exterior to the reaction chamber, 6 inside. 2 oil pumps are used, 1 for each fluid. 1 flow meter is used at the very end on the biodiesel output. This allows us to look at what's happening in the system. And then we have 8 non-precision manual valves that allow different configurations of the system depending upon what we want to work with. So let's start. This is the potassium hydroxide section, and this uses a recirculating system that serves 2 purposes for us in this case. We can use the pump to move methanol from a source, 55-gallon drum, into our conical tanks. This is accomplished through closing the precision flow valve, which is seen here, while opening this valve and closing this valve. This valve is left open, and that allows us to take fluid through the pump and into the tank. Now when we're actually running, obviously we don't want fluid from here, we want it from here, and so we can close this valve and then open this valve, and that allows us to run through the system. The second purpose of this is the mixing of the methoxide. So we can take straight methanol into the conical tank, add our potassium hydroxide, and then recirculate the system to aid in mixing. And this helps, and potassium hydroxide will mix itself, but this limits the amount of time that it actually takes, which is useful. The same system is used on the feedstock. It's for the recirculating purpose, is used in case there's a pressure buildup within the system. This valve will release that pressure without any problems occurring as hoses fly off. We don't want that happening. So this was initially, the pumps in the current state aren't quite powerful enough to do this. But in future upgrades, pumps, maybe a gravitational feed system, this valve will become quite useful. All right,